All right, welcome back to another tutorial. Today we're going to be covering how to debug with Visual Studio Code and command line arguments using both the debugger and the actual command line. So I have a project set up. I have a makefile, file.c, header.h, and a main.c. So the first thing we're going to come do is go into the makefile, change our app name, and we're going to add another flag to the CXX flags. It's going to be a -g flag. But we're going to use -g3. So the -g is what you would use to tell the compiler to add in debugging information. And there's different levels of debugging information. You can do -g0, 1, 2, or 3. The higher the number, the more debugging information you can have. So we're going to leave it at -g3. Also, you're going to notice that just like in the other video showing you how to set up a project, my LD flags are added to line 41 and 48. So we're going to go into the terminal and we can type make, and you can see that it compiled for us with no issues. And on the left there, it put our binary. And we can now run that using /debugging, just like we did when we set up the project. And all this does is print out the powers of 2. Alright, so we're going to go over to the debugging pane, and you'll come up with the screen like this. We're going to click create launch.json and use C++ GDB. You can use GCC7 or GCC. I'm just going to pick GCC. And the first thing that we want to do is note the name and note the program. So we're going to come down to the program. We're actually going to change that for us. And we want to change that to the name of whatever was in our makefile for the application name. And you want to preface that with $brace workspace folder like you see on line 14. For some reason this worked for me, but it hasn't worked with the students that I've been talking to. So note that it matches line 11 in both cases, but you want to prefix that on line 11 in the launch.json file with $workspace folder as you see on your screen. So we're going to go to terminal and configure build task, and notice that it create a task.json from template. We don't want to click this just yet. We want to make sure that we're opening a C file first, and then we're going to follow the same process. So terminal, configure default build task, and then it gives us options for GCC. So that's what we want to make sure that we get so that it populates the correct build task for us. We'll click that, and then you'll have to go into your Explorer, open up the VS Code folder, and the task.json file is there for you. So next thing you want to do is note the label name. So we're actually going to be changing this. First, we're going to delete the command for GCC because we have a makefile. So we're going to replace what's in the arguments. So in between the square brackets, we're going to put in make in quotes, and then comma, -- directory equals $workspace folder. So the $workspace folder is an embedded macro for Visual Studio Code that will expand to the folder that you have open. And then it auto formats when you save. So now we can run the build task by either going to run and then default build task, or you can hit Control-Shift-B and the output will show up in your terminal. So notice that you have that G3 flag there down below, and that's pulling in all the debugging information for the compiler. If you don't have that, your debugger will not work. So notice now if we type /debugging, it runs just like it did before. So we can go to the debugging tab, and now it says you have an error, could not find the task GCC build active file. So we're going to open the launch.json file, and notice down below on line 25 it shows the pre-launch tasks. So that's telling Visual Studio Code, hey, before I launch this, I have to do something. So you need to make line 25 in the launch.json file match line 6 in the task.json file. So we're going to change it to build project. It can be anything you want, ABC, XYZ, doesn't matter. I'm just making a point to use build project because it's different than both of them, but it does match, and that's the key thing, is it has to match. So we can close out of those, and now we can start debugging. And you can see that it didn't rebuild anything because we already built it, and it ran, output all the numbers for us just like it did before, and then it has some extra output for us. So that was really fast. That didn't really help us. So we need to do what's called inserting a breakpoint. So to do that, you're going to hover over on the left side and notice that a red dot came up, and we're going to put that right on the line that is the calculation for the power of 2. And all you do is click, and that will enable. If there's already one there and you click it, that will disable it. And you can right click it once it's there, and you can edit it and put in what's called a conditional breakpoint. So there's different conditions. You can do a hit count, which basically counts the number of times that it executes over that breakpoint. You can do an expression, or you can do a log file message, which will print to a log file. So we're going to do an expression. So when I equals 10 going through that loop, the breakpoint will be hit and then we'll stop. So you're going to see that now. The yellow arrow will pop up on your screen, and that indicates that you are stopped. So if we look in the watch window or the variables window, we can see that I is equal to 10, size is equal to 20, and we can see all the values in our array that have already been populated. But if we go down and look at the 10th item, you can see that it's still 0. It hasn't actually been executed. So when you stop on a line, remember that that line has not yet been executed. So we're waiting for that to be executed. Up at the top here, you can see you have some different options. So you have continue, which is the arrow, step over, step into, and step out of. Those are going to be helpful when debugging. And then you have, of course, restart and stop. So we're going to step over, and now you can see that the arrow has moved. So we went to the bottom of the for loop, and now we're back at the top checking our condition. We can also see in the variables pane that the 10th item in the array has changed to 1024, and it has also been highlighted for us, and you can see that there's other random numbers in the array. So those numbers do mean something for the debugger, but for us they are considered random values and we don't want them there. So then we can do some more step overs, and you'll see that as we step over, things will change. So there's the number 11th one, and we can add other watch variables as well. So we can add ARR to our watch variables, and you can see it matches exactly what's already in the variables pane. So that would be good for using if you have like pointers being passed around. You can monitor those a little easier than using the local variables. So continue to step over, and we can see that I changed. Again, it highlighted. I can't stress that enough. So if you come to a breakpoint, or if you do an action, then it will highlight any changes that have been made. So really pay attention to that variables window. It can be super useful for you. So now I'm going to add another breakpoint down beside print array, and we can hit continue. So continue will just take us to the next breakpoint. If there is no breakpoint, it'll run right through to the end of the program. So now I'm going to show you the step into. And now we're into the print array function. So it actually took us over to file.c. So we've changed files, and now we have stopped just before the for loop is started. So look at the value of I, it's just a random number. And now as soon as we step into that, it's initialized. So notice that the printf didn't actually work if we look down at our terminal here. Like we figured it would, and that's because you need to flush the standard out buffer. So when I execute that next line, now you can see that it's printing. So if you're running through something and you have a printf statement and for some reason it's not printing when you're debugging, just add that f flush standard out and immediately after it, like write the next line, and it will flush the standard buffer for you and print to the terminal. So now we can step out of this function, and it'll take us right back to where we were. So click the step out, and you can see it brought our arrow back to the return 0, which is the line after, and it printed everything out for us, and then we can hit continue, and that ends our program. So the next thing we can do is we can open up our launch.json file, and we can change the stop at entry value to true. And then when we run our debug, so it'll rebuild for us, and we run our debug session, and notice that now it's inserted a breakpoint for us immediately at main. So you can't put one there with your mouse by clicking, and also it's sometimes good to have that so you can see variables before they get initialized. So I'm just going to stop that. That was just to demonstrate that it's possible. In Lab 2, you guys experimented with command line arguments. So in order to do those while debugging, you can actually go into your launch.json and add them into line 12 here where it says the arguments, and again, save, it'll auto format for you. So we're just going to put in the command line arguments of hello world. So through the magic of YouTube, I've gone ahead and input some code here. You can see that I have modified main to accept command line arguments, and then put in a print statement on line 21. So I'm just doing a recompile. So I did a make, there's no errors, and now I can run /debugging. You see it prints out everything just fine. So now if I want to add a command line argument, I can do /debugging. So I'm running this from the command line, remember, I'm not clicking on an executable, and then I add in the argument that I want to pass in. So this can be a file name, this can be a random string, whatever you want. So now if I click the debug window, debug session, we can see that as I step through this, we're going to print out hello world down below. And if you look in our launch.json file, that's actually what we put in as that argument. So that would be how you pass in command line arguments while you're debugging. So if you're running in release mode, you do it from the command line. If you're debugging, you come into your launch.json and put in the statement that you want to put in. All right, so that covers everything for today. As always, if you have any questions, send myself, Dr. Hughes, or Zach an email. And good luck going forward. Talk to you guys next time.